little while ago I had trouble with some car relays, just normal 12 volt electric switches that are controlled by a small switch to control a big switch. It's basically what a relay is. But I had trouble because they kept melting, seemingly being overloaded, and so that has resulted in me having to replace the normal 30, which is what those little cubic ones are. Now the problem is a typical ammeter like this one will go up to 10 amps if you're lucky enough. Sorry, I think the other one I've got is 15. 10-15 amps you can measure, but it's not enough. It's definitely more than 15 amps because the ammeter goes completely full scale, and it's certainly more than that. So the question is, how much more and how do you measure that? And that's the important question. So for that, I've got this thing, and I'm just talking about the black thing here, never mind the wires. This thing is called a shunt, and basically it's a precision resistor. Now if you know anything about Ohm's law, the voltage across a resistor is calculated from the current flowing through times the resistance itself. So if you know the exact value of the resistor, you can measure voltage across it and thereby measure the current. And this is a lot bigger current than you would be able to get from one of these. So this is a shunt resistor, and we're going to take advantage of Ohm's law so we can measure the current going through it. By measuring the voltage across, we should be able to work out what the current flowing actually is. And the way these things work, and I did have to look it up to be honest with you, this is called an FL2 shunt resistor, and it's rated at 50 amps. And the way that it works is that at full scale deflection on a 75 millivolt voltmeter, that would be 50 amps. So if it's 100 amps, that presumably would give you 150 millivolts. But millivolts are quite small things really, and easily measured on one of these. So what I'm going to do with these big wires here, I'm going to wire this into the car, into the relay in fact, and we'll find out exactly what the current being drawn actually is. Right, mystery solved. It turns out that the relay down here has actually got 2 wires on it, and I'd only got one of those going through the shunt. And in fact I think this one that I had before is one that feeds accessories. So I was basically feeding in standby mode, so that explains why nothing much was happening. So having corrected that, let's go back to where we were before. So the meter thinks it's trying to do, so we're going to go into millivolt range. There it is. And we're going to choose, no, I was right the first time. Okay, so switch on. Okay, so let's make a note of that then. All off is in fact 0. Good. All right, so 0. Quiescent with the ignition on. And we get 9.71. Okay, and put the headlamps on. Yes, that is the sort of thing we wanted. Headlamps on is 24.17, and the blower as well. heated rear window on, didn't we? I'll turn the blower off. Heated rear window is one that I kind of worry about. I think it's over here. There it is. HRW doesn't seem to... I wonder if it's working. Interesting. HRW is not reacting to being switched on or not. So that might be something to investigate. Right, never mind. Okay. So let's go with switch on. So for a minute the fuel pumps come on. You've probably heard them. So switch that off for a second and see what it goes to when the let's call it start up. What's the peak? And that'll be the fuel pumps running. Let's have a look. Switch it on. I think we saw 22. Anyway, startup is 22. Well, I suppose the last one I can usefully do right now. Oh, wipers. Actually, I could do wipers, couldn't I? That's wipers. And they are taking about 12. What I'm really seeking to find out is whether I'm at all likely to melt my new 100 amp relay. That's really the objective here. So let's see what happens when the actual engine's running. So I have to get my other leg in. So let's try this then. So we're going to try engine running. We'll do engine running on its own to start with. It's likely to be very similar to the fuel pump figure, which was or the startup figure, which was 22. But let's have a look. With the wipers on, seeing a maximum of 80, let's call it 85 millivolts. I'll switch that off. Okay. So, having calibrated or done the measurements, I've now got to work out what that is in terms of current. So I'll have to go inside and check that. But I think from memory, 75 would have been 50 amps. And we saw a maximum of 85. So it looks like a current draw, I think, of something like 55, maybe 60 amps. And that's with everything running. So that's good news. Anyway, I'll go and confirm or deny that and see how we go. Alright, so I'm going to convert my scroll into something slightly better. And that, if you like, this one here, is the crucial figure for how much current that big flat relay is actually taking. So let's convert that into current, which is what we actually need. There's one combo which I have forgotten to test for, and that is main beam with front spotlights on. So let's test for that. So let's put the ignition on. We'll put the headlamps on, and then we're going to put main beam on. Surprising little difference actually. So that's just main beam, dip beam. So main beam is 26.1 and dip beam is 24. So not a lot of difference. But if I put my lights on as well. There we have those. Now we've got 37. So I've converted my millivolt readings measured across that shunt into amps. So I'm going to have a diagram about this in a second. So just the quiescent without anything much running, we had 9.71 millivolts, and according to my calculations that equates to 6.4 amps. Headlamps, I'm going to I'll do a proper thing on this. 24 millivolts equating to 16 amps. Right, a few mental gymnastics required there, because of course the way I've got the car wired up, you can't have the headlamps on with nothing else. You have to have this quiescent ignition figure, because the headlamps don't work without the ignition being on. So to work out what the power of the headlamps is, you need to deduct the quiescent with the thing just sitting there with the ignition on, deduct the 6.5-ish from the running figure, or the switched on figure, sorry, which is near enough 10 amps. And 10 amps times 12 volts gives you around about 120 watts, which is roughly what you would expect for two 55-watt bulbs, one on each side. So that's just the sanity check to make sure that the basic method, in spite of my confidence in having looked it up how it works, it does appear to be working correctly. So that was my sanity check, as I know that headlamps are 55 watts or thereabouts. That should give you 110 watts for the two of them, just under 10 amps. That's it, between them. 10 amps, and you take the figure of 16, take the quiescent figure away from the 16, you end up roughly 10 amps, and that's good enough. That's good enough for my calculations. So the maxi figure is the important one that we're worrying about, and that is 96. I mean, this what I was just saying confirms that all that stuff is correct. So this gives a maximum load of 64 amps, which you can understand why the 30 amp rated relay failed. Although I wasn't running everything at the time, but you can see why it would head towards the top end of its range. But with the 100 amps, 64 amps is of course only 2/3 of its maximum, so we should be absolutely fine with that figure, and that's an important thing. So this is what we have been doing. We've been feeding all the circuits, whatever they are, but they've been coming from the 12 volt, which is obviously the battery. They've been going through that big fat relay that we've been worrying about, and through this thing, which I shall mention or label as being a shunt. And that's basically a little precision resistor in there. So we've been measuring the voltage across that resistor, and that's what the millivolt reading is. And all the current has been flowing from the battery through the relay, through the low value, it's milliohms or microohms or something, very low value resistor, to the circuits in the car. And we've been measuring the voltage across that very low resistance. And that's given us a bunch of readings in millivolts, because that's how the way it's set up. That's the values that are chosen to give you values in the millivolt range. And those are the ones that we've been measuring. So thinking of Ohm's law, basically voltage equals current, which is usually written as I, times resistance. Or, to put it another way, current equals voltage divided by resistance. And the way I was just doing that calculation, because one of the things that wasn't clear to me was the fact that I couldn't work out easily from this the way the shunt is labelled exactly what the value of the resistance was. If I'd known exactly what R was, I could work out all this stuff very clearly. But the way they've sort of written it or specified it is that full scale on a meter is defined as being 75 millivolts. So when it's at full scale, i.e. 75 millivolts, the current equals 50. So that's what we have to do. So taking all these figures over here, and take the headlamps for an example, which is 24.17. So 24.17 divided by 75. So it's that proportion. We're dividing 24 by 75 in order to get the proportion of full scale that it would have if it was 75, and then multiply that times 50, because full scale would be 50 amps. And if you do that, that's the figures you get. So 24, you end up with 16.11. And I've done that same thing for all of them. So there we go. That's how to measure high currents. And our maximum current that we seem to have managed to achieve is 64 amps, which is a heck of a lot, actually, to be honest. But yeah, that's what it is. And it's well under the rating of the relay, and that is the important thing. So now I'll just have to go and put it back together as normal.